All right, the second half of chapter 13. So we already talked about quasi-experiments, so now we're just talking about some small n designs. So a small n design is a study that has a small n, and n is the number of participants. So some things like case studies, um, where someone has a unique medical condition or has been through something, whatever going on, and they look at the individual and try to like figure out things from them. Right, that's one person, but they're still gaining information and studying that information in that individual. So that's an example of a small n design. So main differences between large and small n designs are in this table here. So for a large n design, typically, obviously, we have a lot of individuals, right? And there's independent variables, dependent variables that are measured, and participants typically are grouped together. So individual data points aren't necessarily super important in a large n design. What's more important is finding the average for a group of participants. So participants are grouped typically by their level or condition of the independent variable, and data typically is represented as averages. So for all of the studies we looked at earlier, even with quasi-experiments, those would be all large n designs. And all the graphs that we looked at showed averages. So the averages of how many individuals were granted parole at certain times of the day, averages of life satisfaction for people who participated in cosmetic surgery versus people who didn't, right? Each group, the averages for the different dependent variables were found, okay? So large n designs presented as groups and averages. For small n design, each participant typically is treated separately. So each individual case is like its own experiment. Small n designs are almost always repeated measure. So you have one person that whoever is researching, and then they're gonna look at everything about that person, right? Um, and then data is represented for each individual person, typically for small n design. So each separate data point, whatever it might be referring to, for each person is important in a small n design. Okay, so for small n design, how we're going to learn about it, we're going to look at some research on human memory, behavior change studies in applied settings, so 3 small n design examples, some other examples of small n studies, and then looking at the 4 validities in relation to small n designs. So first, looking at research on human memory. If you're in my neuropsych class last semester, this should be familiar with you. A lot of introductory psych classes, I know brain and behavior talk about memory as well. But HM was a case study. Man, Henry Molaison, he suffered from repeated debilitating epileptic seizures, and he had seizures for his whole life, and was on anti-seizure medication for a long time. Eventually, the seizure medication stopped working. So HM underwent a bilateral, is a medial temporal lobe removed, which removed bilaterally, so on both sides of his brain, his hippocampus. And most of the information we have now about human memory, we learned from HM. So before this case study, before HM had this procedure done, not a lot was known about different types of memory. This class, obviously, we're not learning about memory, but we have declarative and non-declarative, implicit, explicit memories, procedural memories, all the different types of memory. And before HM, we didn't really know how these different memories were consolidated and learned in the brain. So it was interesting to have a case where it had bilateral removal of the hippocampus, which is really important for consolidating new explicit memories. So a lot of what we learned again on memory, we learned from HM and case studies like HM. So for example, there is this STAR task, which is basically the participant looks in the mirror. They can't actually see the star that they're drawing on, looks in the mirror, and then is told to trace and stay inside of these lines and trace the star all the way around the outside. So over time, with practice, people become better at this task, right? They learn procedural memory, can get better at performing the task with repeated attempts. So they did tasks like this and other different types of procedural tasks with HM. This is him. And because he lost his hippocampus, he had just some anterograde amnesia, couldn't form new memories. So he would do this task one day, the next day they would have him do the task again, and he could not remember that he had ever done the task before. But after time, even though he could not recall and explicitly say that he had ever seen this task or done the task, he got better with time, right? So that's showing that our explicit or declarative memory, saying, oh yes, I remember that I've done this before, the area of the brain that processes that type of memory compared to implicit or non-declarative, so learning how to do the task. Those are two different types of memory and they're processed in different parts of the brain. So even though he didn't remember ever doing the task, he was getting better with practice, which is showing he's still learning and having memory of the task, but it's just an implicit memory, a procedural memory. So obviously, patients like this, we can learn a lot. If they have certain brain damage that affects certain parts of the brain, obviously we're not going to be able to create lesions in a healthy patient to have similar types of effects. But we can study people who have different abnormalities or damage to see, if we damage this, if this part of the brain's damaged, what effects does this have on memory, on cognition, a bunch of different things, right? So this HM, I forget how old he was. I wonder if it says here. Um, doesn't say how old he was when he had the bilateral medial temporal lobe removed, but he was studied for over 40 years. So after his surgery, and they realized, this affects his memory, he agreed to participate in a lot of different research studies. They had him do a bunch of different tasks like this, different tasks, learning different letters, strings of numbers, a bunch of different stuff, and a lot of information about memory was learned because of HM, right? This was the first time we saw something like this, and we're able to study it so extensively. So obviously this is a small n design, right? We have one guy, HM, that we're learning about all these different things with just one person. So obviously, there's going to be some issues trying to generalize this information to a population. So case studies, typically small n designs, are kind of like a starting point. We have to really balance priorities and look at different things such as experimental control, manipulation, and replication in small n designs to make sure that the information you get is really generalizable. So for experimental control, HM did all of these different, procedural memory tasks, looking at photos, all different tasks, looking at different types of memory. And his, you know, memory recall, whatever you want to call it, was compared to aged matched control participants who had no brain damage. So there was control in that you had a control group, a comparison group. And researchers were really careful to design tasks that were meant to isolate different elements of memory. So looking at declarative and non-declarative memory, different procedural memories, looking at retrograde versus anterograde amnesia. So researchers weren't just like willy-nilly trying to, give him different things and see if he could do them. Everything that they did had a lot of thought behind it and was shown that it was a reliable test for testing different types of memory and stuff, right? Um, So it's important that if we're doing small N studies or case studies, things like that, that what we're studying is actually studying what we want it to be, making sure we're operationalizing, have good construct validity on our tests, good reliability and validity, to make sure that we're actually getting the information that we're intending to get from these participants. Obviously, when we're studying special cases such as HM, we can't be certain that the results we see, what we're seeing in the dependent variables that we're trying to measure, we can't be sure that they are actually, affected by what we think is affecting them, right? So when we're looking at HM, he had that bilateral hippocampus removed. So the issues with different memory processing was thought to be because of that. But he was on anti-epileptic medication for a significant amount of time in his life. He had shown to have, I think, prefrontal cortex damage. I don't know if it says over here. Uh, it doesn't say over here, but he had, I think, prefrontal cortex damage, and other areas of his brain were shown to be damaged because of, could it be because of his seizures or the medications he was taking for his seizures. So although, he did have significant amount of tissue removed from his hippocampus, we can't say for sure that it wasn't other parts of the brain interacting as well that was responsible for some of his deficits. And actually, after he died, he donated his brain so they could look and see exactly, what areas of the brain were lesioned. And he still had some small pieces of his hippocampus intact, which might account for some of his ability to retain some sort of memories. So again, when you're doing things like this, looking at patients, we can't be 100% certain, that the entire hippocampus is removed, or if there's not other areas of the brain that are affecting the results that we see. Um, Having seizures, having a lot of these studies are done with patients who have schizophrenia. Obviously, we don't know for sure that the one thing that we're trying to look at is the only thing going on, right? Um, and disadvantages of this, again, we can't really necessarily replicate this. We can't, bilaterally remove the medial temporal lobe on just whoever we decide to do it, a healthy brain. We're kind of just finding cases that we have and then using them to the best of our ability. But replication and full experimental control is kind of out of the question here. Nowadays, we have really cool imaging techniques. We can use fMRIs, DTI, transcranial magnetic stimulation to create like virtual lesions in people's brains that can kind of do the same thing as an actual lesion, but just kind of turn off parts of the brain for a minute. So we can do really interesting experiments now, where some of the stuff, we can replicate to an extent, but still we can't really necessarily have full experimental control, and we're not just going to go open people's brains and cut them up and see what happens, right? Obviously, that's unethical. So replication on this type of thing is not really feasible, which is why it's really important to have the best experimental control that you can, and really, you know, be sure that the tests you're facilitating and, having control groups to compare whatever the case study is you're looking at is really important. Okay, I'm talking too much. I'm sorry. I like this stuff. I like this stuff. This stuff's the interesting stuff, not research methods. Okay, so moving on though, so there's three different designs for small N experiments that we're going to talk about. So the first is called a stable baseline design. So in a stable baseline design, researchers observe a behavior for an extended period of time called the baseline before an intervention or treatment is introduced. So most of the small N designs are going to be more focused on some sort of intervention. So having a patient with Alzheimer's disease, and then having some sort of treatment and seeing if that treatment's going to work in that individual patient, or different issues with autism, trying to have different interventions to help autistic patients cope with issues that they may be having. Typically, small end designs are looking at treatments and trying to determine if they're effective or not. So stable baseline design, again, you have this baseline period where you are measuring, something, whatever it may be, before you're introducing a treatment. The point of this baseline is to ensure that external factors aren't affecting um, the whatever this dependent variable that you're measuring is. You don't have any historical events or maturation, any of those threats to internal validity that we talked about before. This baseline ensures that the results we see are actually due to the treatment that we are giving. So this example is looking at patients with Alzheimer's disease, and they have I forget the name of it. It's an expanded rehearsal technique. So help Alzheimer's patients with word recall. So they want to see if this technique in helping memory of people with Alzheimer's, if it's effective or not. So you would have baseline done, looking at word recall before you introduce a treatment to make sure there's no external factors influencing it. Then you start the treatment and then measure the word recall afterwards. So you can see that after treatment, the ability for the patient to remember certain words obviously dramatically improved. So because we did this baseline, we can determine and say that it's the treatment that's causing this and not some other external factor that's going on. Okay, everyone sees why this baseline is important. If we were to just start the study right at this line and do the treatment right away, we don't know necessarily. Maybe it's because they got better at the test. Maybe it was just interacting with the therapist, wasn't necessarily this treatment. So you have the patient having the test, having interaction with the therapist during this baseline time, so we can rule out some of these other third variables and account for them. Okay, so that's the first example, stable baseline. The next is pretty much the same thing, but called a multiple baseline design. So again, you have that baseline time before you start your intervention or treatment, whatever it may be. But the interventions are going to be more than one, and they're going to be staggered across different situations, times, contexts. So you're going to have multiple interventions with multiple baselines to compare the treatment. So this example is looking at individuals with autism who were scared of dogs, looking at the distance from the dog during the baseline time, and then after treatment. The treatment, their therapist would go with them in a gym and get kind of close to a dog and say, "Oh, come here, like let's get a little bit closer," and then would reinforce and praise the kid. So give the kid something they liked, chocolate, candy, whatever it may be, as they're getting closer to the dog to reinforce, that it's okay to do this and the dog's not going to hurt you, yada yada yada, up until the individual would actually go all the way up to the dog and touch the dog. So again, before we actually introduce the treatment, we want to make sure that we understand the baseline. So make sure this baseline is consistent. So these three multiple baselines, there were different individuals who had autism that were going through the same treatment, right? So we're doing it across different individuals here. So we have a baseline for everyone to kind of get, understand exactly what's happening with each individual, and then compare that to after treatment. And we can see John, Sally, and Bob, both after treatment, were significantly less afraid to go up to the dog. And they also generalized it to new dogs. So they had unfamiliar dogs and did the same thing, and found that after the treatment, not only were they not afraid of that dog that they met initially, but other dogs as well, which is good. Okay, and then the last type of small end design is called the reversal. So similar thing, you're going to have a baseline, again, to see, how the individual is before any sort of intervention. And then we're going to do the treatment, measure that. And then reversal, what happens is you go back to baseline. So you stop the treatment after a while, and then see what happens if the individual is going to go, the behavior is going to revert back to the original or not, to show again that the treatment is actually what's causing the behavior to improve. So this type of a study can't really be used for learning new tasks, something like riding the bike or something like that, that is learned behavior. Because after we teach individuals something, have some sort of treatment period where they actually learn something, they're not necessarily going to revert back, right? Because they already have this learned behavior. So something that's not a learned behavior would be a reversal. All right, then some other studies of other examples, of small n studies. So Jean Piaget was a famous developmental psychologist you've probably heard of, really important in cognitive development in children. So he came up with a lot of different really interesting theories, showing, how children cognitively developed. So one example, looking at the amount of like liquid in a glass. So obviously if you have two glasses that are the same shape and size and they're both filled to the same level, kids understand that they're, the same. But if you're to pour this into a taller glass, they might think that this glass holds more liquid, even though they just saw that you poured it in. So Piaget looked at just a small number of children, his own children. This is not his child. It's just a photo of some other child, and came up with a bunch of different studies trying to measure different cognitive development, different developmental stages. And even though he had small n designs, they were very well operationalized. His experimental control was great. And he learned a lot about cognitive development, even though he only used a small number of people, which were his own children, right? So again, obviously small n designs can be beneficial. Another example, Ebbinghaus. You probably heard of Ebbinghaus. Herman is an experimental psychologist, looked at memory, again, the amount of um, syllables that could be remembered, and, what's it called again? The forgetting curve, right? So in any text, intro to psych textbook, I'm sure you've seen Ebbinghaus. But he just did experiments like on himself to see how long he could remember syllables, different memory tasks he did. But again, even though he only had one participant who was himself, his experiments were very well operationalized, had good experimental control, recorded everything meticulously. So the results that he found could be generalized to other people. So again, small n designs can be very beneficial if the studies are done correctly. And then the very last slide, evaluating the validities in a small n design. All of these, obviously, you should already know: internal, external, construct, and statistical validity. Internal validity can be good if the study is carefully designed. So we want to make sure that we're accounting for any external threats, make sure we have good experimental setup. External validity is more problematic. Small n design studies aren't necessarily looking to generalize to the population. They're more trying to figure out how certain things in psychology work, right? So looking at people with damage to different parts of the brain and seeing what deficits that they have. They're not necessarily trying to generalize and say, oh, if you cut this one little part of the brain, it's going to do the same thing for everybody. It's more trying to understand how everything's working together, and how well treatments work, things like that. So trying to find more effective explanations of different psychological theories and concepts, not necessarily trying to find things to relate to the whole population. Contract validity, obviously, It's what the researchers make it. So it's important that the different definitions and observations, how we operationalize what we're studying, as long as those are precise and there's a really good experimental setup, we're staying, you know, I don't know. Concept validity shouldn't be a problem in a small n design. And statistical validity, finally, again, we're not necessarily trying to generalize this to people. So statistical validity is not necessarily relevant. Um, Obviously, if a small sample size, we don't necessarily have a large effect size in small n designs, but again, that's not really the point of a small n design. Point is more to understand what's going on and try to explain things, gather more information about things we might not necessarily completely understand. Okay, that's it for this chapter. Again, chapter 13 this week, next week's chapter 14, and then our final will be the following week. So I'll keep you updated on everything that's going on. If you have questions, let me know. And I hope everyone has a great week, staying healthy, not going too crazy. I don't know, having fun. I don't know. Okay, bye.